6.2 number 1. Let's get started here. I don't know what I got to do to make this thing stay up. Let's hope it stays up. Stay up. Okay, 6.2 number 1. Let us get started. So, in problem 6.2 number 1, you find yourself standing on a skateboard. It's all pretty standard, except you are throwing your pet. Standard overhand throw of your pet, in my case a chicken. There's our chicken. The chicken is being hurtled. Now, number 1. Okay, so the skateboard has a velocity of 0. The initial velocity of the chicken and everything on the skateboard is 0. But what I'm going to do is I'm going to throw the chicken as fast as I can forward. Forward as fast as I can throw. On my biometric page, it shows that my maximum throwing velocity is 19 meters per second. Yours might not be that same speed. Check your biometrics page. Now, when I throw the chicken forward, Newton's third law and the law of conservation of matter says every action has an equal and opposite reaction. The impulse of launching the chicken forward is also acting upon me, rolling me backwards. So I'm going to roll backward at an unknown velocity. Velocity, merit, final. Now, let's assume that the skateboard has no mass, just to make life easier. Let's assume that there is no friction between the skateboard and the ground. Makes things easier. Let's assume I really could throw a chicken 19 meters per second. I know what you're going to say. Mr. Merritt, when we did that test, we were throwing tennis balls. You couldn't really throw a 7-pound chicken the same speed you can throw a tennis ball. Let's just assume I do. And assume if your animal is larger than a chicken, suppose your animal is a pony, that you can also throw a pony at the same speed you can throw a tennis ball. We're just doing this for the sake of calculation. This isn't exactly a real-world situation. A lot of people would say, Mr. Merritt, I don't think you could even stand on a skateboard and throw a chicken. Probably true too, but let's just say we could. So, let us get started now. The law of conservation of matter says that the momentum of the two objects, so in case the momentum of merit initially plus the momentum of the chicken initially is going to equal the momentum of merit at the end plus the momentum of the chicken at the end. So, let's go with that. The formula for momentum is mass, this is the mass of merit, times the initial velocity of merit, plus the mass of the chicken, times the initial velocity of the chicken. And that's going to equal the mass of merit. Now, by the way, we notice there's no initial and final with the masses because your mass doesn't change. Your velocity changes, but your mass does not. So, times the final velocity of me, that's what we're trying to find. This is the big unknown right there. That's what we're trying to find. Plus the mass of the chicken times the initial, or times the final velocity of the chicken. Let's start plugging things in. From my biometrics page, I know that I have a mass of 108.9 kg. The velocity initially is 0. Plus, the mass of the chicken is 3.2 kg. The velocity of the chicken initially is 0. Okay, that equals, my mass doesn't change. My final velocity is still unknown. But we do know the final velocity of the chicken. The 3.2 kilogram chicken is going 19 meters per second. Now, velocity and momentum all have a direction. The direction of the chicken is that way. So, our chicken is going that way. Let's plug this all in. Okay, 108.9 times 0 is 0. Plus 3.2 times 0 is also 0. All right, that's easy. That equals 108.9 kg times VMF. Plus 332 times 19, I happen to know that's 60.8. Somehow I was able to do that in my head. Kilograms times meters per second is kilogram meters per second. It's kilograms times meters per second. The direction stays the same. All right. 0 plus 0 is 0. We're going to try to get VMF by itself. So I subtract from both sides 60.8 kg times meters per second. Subtracting that from both sides. All right. Now don't forget the direction. Directions can go into equations just like everything else. So what I end up with is negative 60.8 kg times meters per second. That away is equal to 108.9 kg times VMF. Now let's try to get VMF. That's a horrible F. There we go. Let's try to get it by itself. How are we going to do that? We're going to divide both sides by 108 kg. 108.9 kg. Cancel. We're going to have to do some math here, but the kg cancel right off the bat, don't they? Now, I happen to know, I've done this already, we end up with negative 0.558. Kgs are gone. Our meters per second are still there. That away. Now, a lot of people are going to look at that like, can you have negative momentum? Sure you can. I've got, in this case, it's negative that way. Well, if I'm going negative that direction, if I have negative momentum in that direction, it means I'm going this way, right? That's what it means. That's all it means. If you got negative momentum, it just means that whatever direction is indicated, you're going backwards. That's all you're saying. Now, by the way, you may want to change it. You may say that negative 0.55 meters per second, that way is not a happy answer for you. You can change it. Now, by the way, we do need to round 2 sig figs, so I could change this if I wanted to do 0.56 meters per second this way. Either way is fine. Negative that way, positive this way, it's the same thing. So, there you are. I hope this helps you. We're going on with our day.